Hi, welcome to the final part on the topic of limits of trigonometric functions. By the way, please remember to click on the subscribe button below to have complete access of our Calculus Made Easy series. So, our first example for today's video is the limit of sine z minus 1 over z squared minus 1. So, let's rewrite this as the limit of sine z minus 1 all over z squared minus 1. Recall that a squared minus b squared is equal to a plus b multiplied by a minus b. Difference of two squares. So z squared minus 1 is basically a squared minus b squared. So if you follow this equation, difference of two squares, a squared minus b squared is equal to the product of the binomial a plus b multiplied by a minus b. Z squared minus 1 therefore will be z plus 1 multiplied by z minus 1 as z approaches 1. We can rewrite this as the limit of sine z minus 1 all over z minus 1 as z approaches 1 multiplied by the limit of 1 over z plus 1. So basically, this is z minus 1 over z minus 1, and then 1 over z plus 1. So if you recall, the limit of the product of two functions, in this case, one function is z minus 1 over z minus 1, the other function is 1 over z plus 1. The limit of the product of two functions is equal to the product of the limit of each function. So here, just to complete, I just put here z approaches 1. Now, let z minus 1 be equal to, let's say, x. Now, as z approaches 1, as z approaches 1, what happens now to this? So as z, which is also this, as z approaches 1, this becomes 1 minus 1 is equal to 0. So as z approaches 1, x approaches 0. So as z minus 1 is equal to x, as z approaches 1, this becomes 1 minus 1 is equal to 0. So as z approaches 1, x approaches 0. Let me just clean this up a bit. So as z approaches 1, x approaches 0. Now let us rewrite our equation, therefore, to, let me just put the divider here, the limit of sine z minus 1 now will become x all over, again, the z minus 1 will become x. And as z approaches 1, x approaches 0. So we'll put here x approaches 0. As z approaches 1, x approaches 0. Multiplied by the limit of 1 over z plus 1 as z approaches 1. Now, if you recall here, limit of sine x over x as x approaches 0, this is simply equal to 1 multiplied by the limit of 1 over z plus 1 as z approaches 1. You just substitute z with 1. This becomes 1 divided by 1 plus 1. This is now equal to 1 multiplied by 1/2. So 1 multiplied by 1/2, you will get 1/2. So our final answer is 1/2. Going now to our next example, the limit of sine z minus 1 over z squared plus z minus 2 as z approaches 1. Now we can write this as the limit of sine z minus 1. Now let's factor this polynomial. Let's factor it. We can write this as, let's try z plus 2, z minus 1. Let us check. So z times z, you get z squared. 2 times negative 1, you get negative 2. 2 times z plus negative z, you will get plus z. So now as z approaches 1. Now we can write this as, again, this is the product of two functions. We have this function here and another function here. We can write this now, this whole expression, as the limit of sine z minus 1 divided by this z minus 1 all over z minus 1 as z approaches 1 multiplied by the limit of the other function 1 over z plus 2 as z approaches 1. So we have sine of z minus 1 over z minus 1. The limit of sine z over 1, z minus 1 over z minus 1, which is this, multiplied by the limit of 1 over z plus 2, which is this. So now, let z minus 1 be equal to, let's say, x. Now, if z minus 1 is equal to x, as z approaches 1, this becomes 1 minus 1, x approaches 0. X approaches 0. So we can see here, if z minus 1 is equal to x, as this z approach 1, x approaches 0. So as z approaches 1, x approaches 0. So now we can rewrite our expression as the limit of sine z minus 1 now is equal to x, sine x, all over z minus 1 again equal to x, as x. Here, if z approaches 1, or as z approaches 1, x approaches 0. Therefore, as x approaches 0, multiplied by the limit of 1 over z plus 2 as z approaches 1. Now we know the limit of sine x over x as x approaches 0 is equal to 1, multiplied now by the limit of 1 over z plus 2. I substitute this now by 1 over z plus 2. Z is equal to 1. 1 plus 2. This is equal to 1 multiplied by 1 over 3. 1 times 1 over 3 is equal to 1/3. So our final answer is 1/3. And for our final example, we have the limit of sine u minus 2 over u squared minus 3u plus 2 as u approaches 2. So we can write this as the limit of sine of u minus 2 all over, we can factor this, u squared minus 3u plus 2. Let's see, we can factor this. Let's try u minus 2, and how about, let's say, u minus 1. Let's see, u times u will be u squared. Negative 2 times negative 1 is 2. Negative 2u plus negative u will give you negative 3u. So basically, u squared minus 3u plus 2 is equal to the product of u minus 2 and u minus 1. So just to complete, I'll put here as u approaches 2. Now, let me just clean this up a bit. as u approaches 2. Now we can rewrite this term now as the limit of sine, let me just put here, sine of u minus 2 over u minus 2 as u approaches 2 multiplied by the limit of 1 over u minus 1 as u approaches 2. So you have here u minus 2, u minus 2. These are two terms. Sine u minus 2 over u minus 2, which is this. And then 1 over u minus 1 is this. Now let u minus 2 be equal to u minus 2 be equal to, let's say, x. So we can see here, as u approaches 2, as this u approaches 2, what becomes of x? As u approaches 2, 2 minus 2 is equal to 0, so x approaches 0. So rewriting this now, we will have the limit of sine u minus 2 is basically, u minus 2 is equal to x, so sine x, again u minus 2 here is x. As u approaches 2, x approaches 0, x approaches 0, multiplied by the limit of 1 over u minus 1 as u approaches 2. Limit of sine x over x as x approaches 0, we know the answer. It's already 1, multiplied by limit of 1 over u minus 1 as u approaches 2. We just substitute u with 2. This becomes 1 over 2 minus 1. This is now equal to 1, multiplied by 1 over 2 minus 1 is 1. So 1 times 1 over 1 is 1. So our final answer is 1. Well, I hope you guys learned the necessary techniques to handle limits of trigonometric functions. We'll be having more examples on limits, but concerning other topics. So hope to see you soon on the other videos. Thank you and sayonara.